Hello, this is for Calculus Chapter 1.2, Part 3, which is introducing all other functions other than polynomial functions. So we give them names and we want to analyze them in more details, in particular domains of the functions and also how to graph them. Okay, so first is other than polynomial function, if we combine polynomial function by add, subtract, multiply, and divide, and taking root, we will introduce something called a group of functions called algebraic functions. And in particular, we will have two types that are very important. One is rational functions, which is quotient of two polynomial functions. So we have p of x, which is a polynomial, and q of x, which is another polynomial. And if we have a function like that, that is called a rational functions. Rational functions are very important in calculus because rate of change is a ratio, right? It's a quotient. And in the beginning of the calculus study, we study rate of change. Another function that is also quite important is the root function, where f of x is equal to a x to the 1 over n. That means you are doing root of x. So the first we want to do is to understand these two functions is to look at their domain, because these, for polynomial function, the domain is all real numbers. That's the natural domain. And all the add, multiply, or polynomial algebraic function also have a all real number natural domain. But for rational and also the root function, the domain is a little different, because we do not want to divide by 0. So if we have a rational function with a polynomial function in the denominator, our natural domain would be ignore or take out or exclude. Yes, exclude all the x value where the denominator x minus 5 is equal to 0. So in this case, that means I want to exclude x equal to 5. So the domain would be all real number x, such that x is a real number except 5. And in an interval notation, you would say 5 as a whole. Then you have all the other numbers. So it becomes negative infinity all the way to 5, and then union 5 to infinity. This is the interval notation for domain. What about I have a root function of a square root of x minus 3? We know that we cannot do square root of negative, so square root must be non-negative. Okay, it can be 0, but it has to be non-negative. Okay, so maybe I'll put it here, 1 over non-zero. Right? So non-negative, how do I make sure that this is non-negative? We would say x minus 3 has to be greater than or equal to 0. So that means x has to be greater than or equal to 3. So in the number line, that means you start from 3. Oh, this is 3. And then you have all the numbers here. So in terms of the domain, it would be 3 all the way to infinity. Okay. What about if I have a cube root? Do I need to worry about negative? No. Cube root or any odd root, the input can be negative as well as positive. So the domain would be all real number. So there's no restricted domain for the natural domain is just all real number. So that's algebraic function, and in particular rational function and root function. So what other function do we have? Other than algebraic function, polynomial function, and all those, we also have a set of functions called transcendental functions. So these are functions that are not generated by algebraic operation of polynomial function. And we have two big types. One is a trig function, and the other is exponential and log function. So this will be covered in more detail in 1.3 and 1.4 and 5. So these are just the two classes. If you see sine, cosine, tangent, cosecant, secant, and cotangent functions, so these are trig function. And for exponential function, they are of the form b to the x, where b is the base, greater than 0 and not 1. A log function is the inverse of the exponential function. We'll talk about those in more detail in 1.5. So let's learn how to classify them. Why do we need how to classify them? Because if we classify them, then we know that, oh, I can actually analyze them, or, oh, I know that, okay, if it's a root function, I would need to be careful about the domain. Or if it's a polynomial function, I know that, oh, I need to, I know how to do the end behavior. So it helps us to analyze the function and graph the function. Okay. So let's see how do we classify it. So I have an example here. So A is x square root of x squared minus 1. You see this kind of function in chapter 4 when we learn how to graph them. So what kind of function is it? Just a root function? No, because it has an x outside, so it's a combination of all those. So I would say this is algebraic. So it is a combination of add, subtract, taking roots and multiply a polynomial with a root function. So it's not particularly a root function. What about x over x squared minus 1? I see that the top is a polynomial, the bottom is a polynomial, so it is a rational function. It's a type of algebraic function, but it's also a polynomial. You can also say it's algebraic, but it is not a polynomial function because you have dividing. And what about f of x equal to 3 to the power x squared? So the unknown is in the exponent, so this, of course, is called exponential function. And the last one, f of x is equal to secant of 4x. This is a trig function, right? It involves the secant function. So this, you need to, name them. And you know that, oh, if it's a rational function, I need to worry about domain. The root function, and it is an even root function, I need to also worry about domain, etc. So it just tells us, it helps us to, analyze them and graph them. So we need to graph some of the basic function, because when we learn calculus, a lot of times we would use this basic function to model change. And we also would use a lot of practices, do a lot of practice graphing with these functions. So it's good to know how to graph them. The first is f of x equal to x. It is just a linear function with a slope of 1. So it's also known as identity function. So it would be graphed like this. Key point would be 0, 0, 1, 1. Okay. So f of x equal to x squared is the parent function of a quadratic function. X to the cube is a cubic function. It's a very typical odd function. 1 over x is a rational function, right? So we have a polynomial in the numerator and denominator. And sometimes it's also known as the reciprocal function, because it's just a reciprocal of the identity function. So how do we graph it? There is a domain restriction of not equal to 0. So at x equal to 0 is not going to it will be excluded. So at x equal to 0 there is a vertical asymptote. So the function is cut up in two parts by these vertical asymptotes. X equal to square absolute x is a function that has two parts, positive slope, negative slope, so it's like a V shape. This is a typical square root function, so the restrict domain is x has to be non-negative. So you can only have this branch, and they increase, but they increase very slowly. Okay, the cube root function is a root function, but because the root is odd, so the domain is all real number, and it turns out that the graph is like that. Okay, so 2 to the x is an exponential function because x is in the exponent. So the graph, the typical graph would be like this. It shoot up after x is equal to 0. Okay, at x equal to 0, it's going to be 1. So there is a key point of 0, 1. Other than that, it's shoot up. At x equal to 1, it would be 1, 2 because 2 to the 1 is 2. Sine function are the atypical trig functions. So we'll go into more details on these. So the sine function is an even function. So the basic period is like this, but you suppose it to go, oh no, this is an odd function. I say it wrong because you see how when you turn it upside down, it's the same. Okay, so this is how you do the sine function. Cosine function is even function. This is an even function. So the main period go like this. One period is 2 pi, okay, from 0 to 2 pi. And of course, you can go on forever, and obviously you can see that it's an even function. Log base 2 to the x function is the inverse of the exponential function, so it graph like this. Instead of 0, 1 now, it has 1, 0. Okay, and then f of x equal to square root of 1 minus x squared is also a square root function, but it is part of a circle, unit circle. So it's a semicircle from -1 to 1. We cannot do the whole circle because obviously that is not a function. So these are the basic one that you can use to graph all the other function. Kind of you need to know how to do them. How do we do transformation? So if I don't have a 2 to the x function, but I have 2 to the x plus 1, how do I do it? So these are the function transformation. If you add a constant outside of the function, that is up or down. Okay, translation up, translation down. If you multiply a number, or if you add and subtract in the input x, then it is a left and right. So plus c is going to the left, minus c is going to the right. Right translation or right shift. Multiply a negative to the whole function would have a reflection over the x-axis. And if you're inputting negative x, then you would do a reflection over y-axis. Multiply a constant outside of a function would have a vertical stretch or strange. So if c is greater than 1, it is stretch. If c is less than 1, it's strange. And if you multiply the input, instead of x becomes cx, then it becomes a horizontal stretch and strange. And the stretch and strain are kind of opposite. Meaning if c is positive, it becomes a strain. If c is negative, if c is less than 1, then it becomes a stretch. Okay. We can do some example. We only have like 2-3 minutes. So I'm going to do one where is the quadratic parent function, or the basic function is this. And compared to x squared, this would involve a reflection, vertical reflection, and also a shift to the left by 2, up 3, and also a reflection. So the graph would be originally like this for basic, and then you do left by 2, up 3, so and then a down. Okay, so that's how you scratch it. This is the from a basic function of square root x. So obviously we also have left or right, left 3, and then vertical stretch by 1/2. Not translate, but stretch by 1/2. So we would have left 3 and then make it shorter like that. So that's how